this video, we will learn about how you can create custom text classification solution using Azure AI language resource. So by now we have clearly understood what is NLP. It is nothing but field of artificial intelligence where computers are made to understand and respond to human language. So you are going to teach your computers to read, interpret and also generate text or speech just like humans do, right? So now when it comes to analyzing your text using NLP, you have different features available in your Azure AI language resource. Like it can review whether your text is positive or negative. That means it can do sentiment analysis, right? Or it can also identify the language. Apart from that, you can develop a custom text classification solution using your Azure AI language resource. So using this custom text classification, you can classify your text into different categories that you want your text to be categorized to. So Azure provides many different models. There are ready-made models also to perform these text classification tasks, or it has the ability wherein you can create the custom text classification models. You can train your own models using Azure AI language service resource, and you can easily integrate them into your applications for the tasks like sorting the customer feedback or categorizing your text files, right? So we will look at what are the different types of classification projects that you can build using Azure AI language service. So custom text classification means you are trying to assign labels to your text files. So let's say you have a text files which belongs to certain domain, and you want to categorize those text files based on your business. Let's say you have a video game business and you have different types of video games wherein you have documents for your video games, right? You have some text summary for your video. Now you want to classify those text documents as per the genre of the video game that it belongs to. Like it can belong to adventure, it can belong to strategy or action or sports, right? So now we have got two types of custom text classification project. One is single label classification and then another one we have is multiple label classification. So when it comes to single label classification project, each text file can be assigned only one class. That means you will be categorizing each of your text file under one label. For example, if your video game summary can be classified either as adventure or strategy, but it cannot be both. So for each of your text files, so here you have your text files, only one label will be assigned, right? When it comes to multiple label classification, each text file can be assigned with multiple classes. So that means, so your this particular first file, let's say, can be labeled as label 1 and also label 2. So these kind of requirement comes, let's say you have a video game summary which can be classified under both adventure and strategy. That means it is having both features. It is having the features of adventure also and strategy also. So when it comes to these kind of classification where you can either do single label or multiple label, it becomes very, very important how you are labeling your data when you train your model. So when you're trying to build such models which can classify, so this becomes very important that how you're labeling your data that you will be using for training your models. So in your single label projects, each file gets one class. So this will be not very complex. So here you can use like certain set of data wherein your each file type will assigned with one label class and you can train your model. But when it comes to multiple label projects, your each file can get multiple classes, right? So as per multiple label classification model, your each file can be classified under one or two or three labels. So in this kind of models, it becomes very complex when you have to train these kind of models. So these kind of models require clear and more varied data for training. So that means you need to use more and more different types of data, wherein your files will be classified under two different labels. So that your model should be able to clearly understand that, and it can provide you the accurate results. Now here evaluating and improving your model becomes very important. So you have to evaluate the performance of your text classification model, wherein you need to find out how well your model is able to predict correctly, right? So it involves, like, you need to understand the type of error that your model has made when classifying your files, right? And then how many it has detected positive, how many it has not detected correctly. So based on these errors that you identify, you can improve your model by taking some measures. Now there are certain metrics that you need to use. So before that metrics, you need to understand what are the different types of classification errors that you can measure. So there is something called false positive. So this is nothing but if your model predicts label X, but that is not actually assigned to the file. So when you are testing or evaluating your model with your test data, let's say your model is predicting a label X for a particular file, but that label is not the one that is assigned to the file. So that means it is predicting, we'll say it as a false positive. Now another kind of error, classification error, we say it as a false negative. So that means your model is not able to predict the label X, which is actually assigned to the file. So you have assigned label X to a file, which your model should be able to predict, but due to some performance issue or error, it is failing to predict that label X. Then we term that kind of error as false negative. Now using these two, false positive and false negative kind of classification errors, there are three primary key metrics to evaluate your model performance. Okay, first one is recall. So recall is nothing but ratio of your true positives to the total number of actual labels. So basically it measures how well your model is identifying all the relevant labels. So it is nothing but the ratio of all the labels that it has identified to the like out of which how many are true positive, right? So either it has identified or not identified all those labels. Out of all those, how many are relevant? That is your recall. And when it comes to precision, it is nothing but ratio of true positives to the total number of predicted labels. So here in recall case, we are taking all the data, whether it has been identified, whether it has been predicted by your model or not. So that we are taking in the denominator. But in the precision, how do you calculate? It calculates the accuracy of model's positive predictions. Like how many positives are there, the ones that are identified by your model, and the ones that are identified by your model truly, and ones that are identified by your model false. That means they were not actually the positive, they were not actually the correct label, but your model has identified them. So out of all those labels, predicted labels, how many are true positive? So here we are checking the true positives with respect to total number of actual labels present in your data. In precision, you are checking how many are true positives out of the labels that are identified by your model. And then you have a third matrix called F1 score, which is nothing but the harmonic mean of your recall and precision. So it is actually this particular matrix will balance both the metrics. It will provide the single score. So here based on recall and precision, you can calculate F1 score, based on which you can decide the performance or you can evaluate your model. So once you have evaluated your model, you need to improve your model, right? So for single label projects, you need to identify which classes are not well classified. You need to identify those kind of data, and you need to gather more quality data for these underperforming classes. That means the classes and the categories which were not correctly identified in your text, those kind of text belonging to those classes, you need to gather more and then you need to retrain your. Similarly, for multiple label projects, here it becomes more complex due to more combination of labels for each text file. So you need to find more high quality varied data wherein you have more combination of labels for each of your text data, and you need to retrain your model to improve its performance. For example, let's say if your model correctly classifies action games and some action and strategy games, but it fails to classify the games which are only strategy, which should be marked as only strategy, then you need more diverse and high quality summaries for both action and strategy games, because here you have strategy and action and strategy. So there are some text which belongs to both action and strategy, and some text, some video games which belongs to only strategy, right? So you need to find that text summary of those video games which belongs to both action and strategy games. You need to find those kind of data and then train your model again. So this process becomes more and more complex as the possible class combination increase. Now coming to how do you use this Azure AI language API for classifying your projects, for building your single label or multi-label classification project. You can use the REST API. Here you can have this kind of JSON request wherein you can use this API call to interact with your models. So when it comes to single label classification project, this is the JSON request that you submit when you're trying to train your model. Here you need to explicitly specify, you see this project kind. So this project kind is here custom single label classification. So this tells that we are trying to train a single label classification model. Okay. And in this request, you will be specifying all the classes, all the categories that you are trying to classify into. So you specified, let's say class 1, class 2, and then you provide your training data where you label your data. So this is your document. Okay, first document, and you are classifying under class 2. So you are labeling it as a class 2, and then you have another document, you are labeling it as a class 1. So that way you can add more and more data here and label them, and then you can provide this JSON request to your Azure AI REST API to train your custom model. Similarly, for multi-label classification, you need to specify project kind as custom multi-label classification, and here also first you need to define all your classes or your categories that you want to assign, and then under that you are specifying your training data. Now in your training data, so let's say you want to classify some text under both class 1 and class 2. Then you using that training data here, you specifying the document name and you specifying the categories that you want to classify it under. So this is your training data, right? So here you're labeling it with both the classes. Okay. So that way you can include more and more similar kind of data so that your model will interpret correctly. Now let us see how do you build a text classification project. So this is just a sample JSON request that we have seen. Now let us see what are the steps involved when you build a text classification project. The first and the foremost step is defining your labels. So you need to first identify the different categories of your text data. So based on your domain, based on your business, based on the requirement for which you are trying to build this custom text classification project, you need to identify all the categories. Okay. Like let's say for a video game, it can be action, adventure, strategy, or any kind of category that you want your text to be classified into. Just first define them. Next is tag data. So now you need to make sure that you label or tag your training data very precisely, very correctly with all the defined categories that you have defined in your this first step. So you need to make sure that you use different kinds of data with and covering all the categories that you have defined. Okay. So once you have tagged your data properly, then use this labeled or tagged data to train your model. So now your model should be trained well enough with good quality data so that it can provide you the correct predictions for your new data that you will supply to your model. So once, let's say, you have trained your model, then you have to evaluate the model performance using the metrics that we have seen, that is precision and recall scores. So your model will be classified, scored between 0 to 1 based on this precision and recall scores, and you can identify whether your model is not performing good, and if there are any errors, if it has not predicted some of the data correctly, then you need to go to improve model. So under improve model step, you will be refining your model, you will be retraining your model by adding more varied and high quality labeled data. So once you identify what kind of data it is not able to predict correctly, or what categories it is not able to classify, so try to gather more and more data under those categories and retrain your model. So once you are satisfied with your model performance after retraining and again evaluating, you can go and deploy your model. Okay, so once you deploy your model will be available to use via the REST API, and then you can query your model to classify any new text. So this is the complete project life cycle before you start building your text classification project and then start using your REST API to classify your text. Now another important aspect is splitting your data sets for training. So now whatever data set that you have to split under training set and test set. So 80% of your label data should be used for training the model, and 20% of your label data should be used for evaluating the model. Now how do you split this data set under training and test? So you can do a automatic split or manual. So if you select automatic split, Azure will automatically or randomly split the data into training and test sets. But this kind of automatic split you use when you have large data set. Okay, and when it comes to manual split, you can manually assign the files like 80% to training and 20% to testing sets. So here you will have your own control over the data distribution, like how you want to split. And manual split is recommended for small data. Now coming to deployment options. Now here it also provide you that you can create multiple models and deployments to test and compare. That means you can use 2 or 3 models. You can train 2 or 3 models and then test and compare them. And your each project, your each custom text classification project that you will create in Azure AI language resource can have up to 10 deployments. That means you can create 10 models, and you can name those models so that you can identify which model has performed well, and then you can use that particular model to classify your text. Now let us see how you use your REST API, okay, to do all the tasks of training and then querying your model. So first and foremost important thing is authentication, wherein you use the Azure subscription key, which you will obtain when you create your Azure AI language resource. You will receive an endpoint and key, right? So that key you need to supply in your this particular header. So when you have to submit your initial request to train your model, so this is the request that you submit to train your model, you need to specify your endpoint that you have received while creating Azure AI language resource. Then you specify what we're trying to use, language resource, and what we're trying to do here, analyze the text. Then projects, your project name that you will create, and what we're trying to do, train. And under JSON body, you'll specify your model name, because we can train multiple models. You need to specify model name to identify, and then evaluation options. So here you will specify the percentage, how much training split percentage and testing split percentage of data. That means how your data should be split when your training is happening. So once you have started training your model, you can check the training status by submitting a GET request to your API. Okay, here just include the endpoint. So this particular GET request will include the response wherein your status and the completion percentage will be specified, like how much training has been completed. And here same, you will call the similar kind of endpoint, and then language, project name, and then train and jobs, job ID. Here we are doing a GET request wherein specifying the job ID. So once you start your training, a job ID will be generated. That job ID you will be specifying here. Let's say your model has been deployed successfully now and trained. Now you will will have to submit a text for classification. Now you have to query your model to classify your text. So you need to submit a post request using the same endpoint, language, analyze text, and then you specify the jobs. Okay, it's a new job you are trying to create, wherein you are trying to classify the text where you are submitting the post request. And under post request, this is the JSON body that you will be submitting. So in this JSON body, if you see what we are trying to do, we are trying to classify the documents. Right here, your input, the tag would be analysis input. Under that, you will be specifying the document. So this is your first document, text with text 1, and then you also specify which language it is in, ID you specify, and then let's say you have another document with text, and here you specify the tasks that you want to carry out, kind of task that you require, whether you are trying to classify, single classify or multiple classify. And then you have a parameters wherein you specify which project name and which model name you are trying to query. So here you specify the deployment name, which will tell your system which model you are trying to query from. Once you have submitted a post request, now you want to retrieve the classification results. That means you want to check what under what category your document is classified, or what your model response is for your text class. So you can do a get request wherein you submit again the same endpoint, and then you try to find out the job ID from the job that you have created above, and then specify the job ID here in your get request. So this response will contain the classification results for your submitted documents. Okay, so for this particular job ID, it will retrieve the response of your model. So you need to specify this job ID, and this job ID would be the job that you have created while when you have posted this request. So we'll see all these steps when we do the lab demo. Now we've understood that you can create your custom text classification project using Azure AI language service. Thank you.